So we will start with the headbox. What are the parameters which will be controlled in the headbox of the paper machine? So basically headbox is the main supply tank basically, which will be supplying the stock to the paper machine. Right? So velocity of the jet, that means the speed at which the slurry will be coming on the wire section, that will depend on height in the headbox or level in the headbox. So first of all we can control the level inside the headbox. If it is tank type, so there are mainly two types of the headbox. One is the tank type, second one is the hydraulic headbox. In hydraulic headbox we are not having the tank, but having the large bank or number of the tubes which will be supplying the stock. Is it clear? So basically in the tank type headbox, which is mainly used up to 400 meter per minute velocity of the machine or speed of the machine. Once we are going above 400 meter per minute, mostly we are using the hydraulic headbox. But again the pressure at which the slurry is coming out, that's a very important, right? So you can control the pressure by adjusting the level, and second one is the extra pressure that is provided on the top of the liquid level with the help of the pressurized air. Is it clear? You can control the pressurized air pressure and level inside the tank. Higher is the level of pressure, more with the jet velocity. What is the second important point? That is the opening or slice opening of the headbox. You can adjust the fiber orientation by adjusting the slice opening. So there are two types of the slice openings basically. You see the headbox slice opening, it's like this one. And this upper slice, it can be adjusted. Angle can be right, it can be here, it can be on this side, like this one. You can adjust the angle here. If you are increasing the angle from here, what will be happening? The space will be narrowed down. So more it will be coming this way, vertical increase. If you are having the medium, the stock will be coming like this one. On the higher one, it will be going slightly on the far away places. So here we will be placing the forming board. This section is called as forming board in the paper machine. So basically the angle will be changed. Angle at which jet will be striking to the screen or wire, that will be changing with the change of the angle of the upper lip. Second option is we can increase, shift the lower lip in the X direction, in this direction. That means you can forward the lower lip to the front side here, in the direction of the movement of the wire. So basically here, just above the forming board, we are having the screen. It will move in this direction. What will be happening? If we are having the vertical impingement, basically rate of filtration will be higher. Time that will be available for drainage, that will be lower here, because more vertical force will be applied here. And if the jet velocity is like this one, parallel one, going slightly far away places, what will be happening? It will be having the vertical component of the velocity. So it will moving in the here in this direction, so drainage will be slow. So you can adjust the direction of the flow here so that vertical component and horizontal component of the jet velocity will be changing here. Are you getting the point? And by adjusting this change, we can control the different important quality of the paper. First one is the tensile strength. So basically tensile strength is measured both in the wire direction as well as in the cross direction. So whenever we are measuring the strength of the paper, we are measuring in two directions. Like if you are taking the page from a notebook, you will find it's having the two directions, one is the lengthwise and widthwise. And if you measure the tensile strength by taking the sample, both the directions will be having the different strength. And there will be significant difference. That means difference will be nearby to, take for example, 20%, 30% like that. Are you getting the point? That means this is a sample paper here. You can take the sample here. First of all, you can cut in this direction. You take the sample in this way. Second one is, you can take the sample like this one. In this way. For example, this is the direction of the machine in which the machine is moving, wire is moving. This is called as the machine direction sample. Right? And this will be called as the cross direction. Direction in this one. So all the paper manufactured will be having the two directions. One is the machine direction, another one is the cross direction. Like here, machine is moving in this direction, then paper will be coming out. So sample taken in this direction is called as machine direction, and across this one at the 90 degree it will be called cross direction. So all the strength properties, like if you are taking the sample for the tensile strength, then folding endurance, getting it? Whenever the sample is taken in the rectangular form, it's having the one dimension more than other. Like here, in case of the tensile, mostly length will be taken nearby to 15 centimeter and width will be nearby to 1.5 centimeter only. So it depends the length is taken from which direction, machine direction or cross direction. Mostly the machine direction strength will be more. That means this direction will be having nearly 25% extra value for the tensile strength. It will be higher. Right? So if we are running the paper in the printing machine, take for example, we are making the newsprint or newspapers or printing the books, it should be run in which direction? In the machine direction. So that tensile will be more and chances of breakage will be less. Are you getting the point? So that's a very important. And this one, the difference can be adjusted by the flow from the headbox. Right? So if you are having the more horizontal flow, that means the horizontal velocity is more here. That means the velocity will be having the two components. One is the horizontal component. That means in the x direction, in which the wire is moving, and second one is the vertical component. That means in the direction of the gravity, which will be causing the drainage. Right? The gravity component will be here in this direction. G is acting here, it will cause the drainage, and this one is the x direction, it will cause the movement of the slurry. So what will be happening here? Take for example, the fibers are here in the slurry. Right? Fibers are like a small filament. If it is moving in the forward direction, mostly you will find just like you are experiencing the force while traveling in the train. If you are standing in a train is moving, what will be happening? You will be falling in the direction of the train or in the cross direction? You will be falling in the direction of the train only. If it is accelerating, you will fall backward. Like here, it is accelerating here, moving this direction. Then you see fibers will be falling like this one. Backward falling. Getting it? So higher is the velocity, relative velocity. This is the direction for the jet velocity. And it will be balanced by the velocity of the wire. Wire is just like the moving train. The train is moving at certain speed. Say for example, this one is moving at the 80 km per hour speed. And jet is moving at the speed of the 90 km per hour. What will be happening? It will fall in the forward direction. right? Because the velocity is more. Another case is 80 kilometer, this one is moving at the 70 kilometer per hour. What will happen? Fibers will fall in the backward direction, like this one. If you are standing here, fall in the backward direction. Right? So if you take the microscopic picture of the paper here, you will find it's having a certain direction here. And most of the fibers will be having like this one. More alignment in the machine direction. This is the machine direction. It's a called as MD. It's a cross direction called as the CD. Are you getting the point? So here, strength is more in the machine direction. So take for example, our task is to get the higher strength in the cross direction. What are we doing? Or what can we do? We can decrease the difference between the wire and jet velocity. If we decrease the difference, that means the difference of the velocity from wire to jet. That means both are moving at the same velocity. What will it mean? If you are having most of the fibers non-aligned, that means the fibers will be in all the directions. There is nothing like any relative force or direction here, so it will be having the more uniformity. Right? That's why it is said that the ideal condition is jet velocity should be equal to wire velocity. And jet velocity is equal to wire velocity or jet to wire ratio. It's called as a jet to wire ratio is equal to 1. Right? Jet to wire ratio is 1, then we are having the distribution of fiber in all the directions. So the difference between the strength in the machine direction and cross direction will be minimum. And wherever there is more difference, that means this one is, say for example, jet to wire ratio is less than 0.95 or it is more than 1.05, then the difference will be very high. So our task is it should be varying between 0.95 to 1.05. Maximum 5% variation either in the higher side or on the lower side. Is it clear? So this is the way to control the properties of paper based on the operating parameters of headbox. So we can either increase the opening of the headbox or decrease the opening of the headbox to control the jet velocity so that jet to wire ratio can be controlled. And by controlling this ratio, you can control the different strength parameters. Second one is the formation again. Again the formation will be good when we are having the jet to wire ratio equal to 1. Because the fibers will be aligned in all the directions. So it will be making the more uniform paper. If you see the paper in the light, then you will find fibers are aligned in all the directions and it is more uniform. So that is called as a good formation. Sometimes you are in the cloudy formation, like on the one side some more fibers are here. This one is called as the cloudy formation. And that is considered bad. That means if the paper is having the more cloudy formation, it will be rejected. Is it clear? So first of all, it will be impacting the strength properties, then it will be impacting the formation of the paper. And based on the formation of paper, again the optical quality will be very clear. In optical properties, we are having the brightness and density. If the more fibers are there in some location of the paper, that means here the opacity will be more. At some point opacity will be higher, some point opacity will be lower. That is again the negative aspect of the paper. Right? So in this way, basically from the headbox you can control the strength properties. Again, the optical uniformness of the brightness and opacity and formation. Right? See the second point.